In the preceding movie, we managed to complete the data manager.c# class to hold all of the game data we're going to be saving to an XML file, but we still need to go back to the game manager class and make it interact with the data manager so we can actually transfer out the real game data in the level, the player and the crate data, into the structures we've created that can be serialized to a file. So I'm going to switch back now to the game manager, and I'm going to be adding two new variables to our game manager class. The first one is going to be private data manager dm equals null. That's going to be a reference to the data manager class where we're going to be holding all of our game data. But I also want a reference to the player controller class in the level because I'll need access to the position of the player and the general status of the player. So I'm going to be creating a private variable for the player controller. Let's just spell that correctly, it's case sensitive. So player controller PC equals null. Again, we're going to initialize that to the variable of null. Both of these values I'm going to populate in the awake function here. So the data manager, we're going to be initializing that to a new instance of the data manager class, like so. And the player controller, well, I'm going to be getting the player controller in the level. So I'm going to be saying player controller equals, and we're going to say game object dot find objects of object of type. There's only one player controller in the scene, and we're going to be finding player controller like so. And that function call there will give us the reference to the one and only instance of the player controller in the level. There's only going to be one instance of it because there's only one player. So in this call here, we create a new data manager, and in this one we create a new player controller. This will be necessary to get the position of the player so that we can save it to a file. So that's a good beginning. We've initialized these values for the game manager, but of course we need to move on. I'm going to be creating a save game function for this game manager class now, which will take the data out of the level and put it into the structures we've created here, the serializable class, so that we can save that data. We'll be looking at how to do that next. So now we've added the data manager, the DM variable, to the game manager class, as well as the player controller PC variable. And we create or initialize both of those variables down here in the awake function. We create a new data manager and we retrieve a reference to the player controller object so that we can save the position of the player. What I want to do now is to add a save game function to the game manager class, and whenever we call this save game function, it will save an instance of the game to an XML file, the status of the current level. So I'm going to scroll down to the bottom of the game manager class right here, insert my cursor, and I'm going to paste in some code that I've already copied off screen. So I'm going to press Ctrl V on the keyboard to paste in this code, and you can see the code here is a save game function. And now let's take a look at exactly how this function works. In the first line we have dm.gd.bd.clear. Let's see exactly what's going on here. We've got dm, and we know that that refers to the data manager variable that we've added to the game manager class. And the gd variable, if we jump back to the data manager class, you can see that the gd variable is an instance of the game data here. So this refers to the serializable game data structure. So I'm going to jump back to Game Manager. So what this line does is that it effectively clears out the list of boxes in the game data structure. So it says we're initiating a new save operation. There may be previous data left over from previous save operations, but we're not interested in those. What we want to do is to completely clear out the list of boxes, if there is one, and we're going to be adding the boxes in the level to a completely new list. So here we cycle through all the boxes in the level. You can see this for each loop cycles through all crates in the level, and you may remember from a previous part of the course, if I scroll back up here, that we create a private array here of all the crates in the level. So we have a crate array, there's a crate component, and we have an array of all crates in the level. This array is populated further down here in the awake function, where we get all the crates in the level using the find objects of type function to retrieve all crates. So I'm going to scroll down here back to the save game function we're working on. We cycle through all the crates in the level, and here is where we populate the transformed data for the box. So we create a new box data. We say for the transform X, Y, and Z, we get the transform position for each of the crates, and also for the rotation. Notice that the rotation is being taken from Euler-Angles.x and Euler-Angles.y and z. It's not using the quaternion data directly, it's using the transform.Euler-Angles component, and here we've got the local scale.x, y and z, and we also record whether the box is on its destination. And then finally, of course, we return back to the data manager and call the add function to add the box to the list. If I return back to the data manager, you may remember here in the game data structure, we use the list object, which is BD, to create a list of boxes. So in the game manager class, when we call the add function here, we're calling the add member of that list class to add this newly created serializable box data to that list. So we cycle through all the crates in the level, and for each box we create this new serializable data and add that to the box list. And by the end of here, when we complete this loop, all the boxes in the level will have had their data translated into a serializable form in the game data structure, ready for saving. But of course, the box data is not the only thing that we want to save. We also want to save all of the player data as well. In our case, all we're doing is we're saving the player transform data, and you can see that here by using dm.gd.pd.player_transform, and we're saving out the position, Euler angles, and the local scale for the player character as well. We're loading all of that into the player data for the game data object, and we're saving that to the file. Finally, we actually save the game data. And it's important to see how we're doing this. We're calling on the data manager save function. If I switch back to the data manager save function and I scroll down, you can see we've got the save function that we've coded here previously, and it accepts an argument to a file on the computer, an XML file that we're saving to. I'm going to jump back to the game manager, and you can see how we're piecing together this local save position here. We've got the gamesave.xml file, but notice that we're prefixing it with application.persistentDataPath. Now the actual value of this variable will change depending not only on your operating system but also on your computer. It can change across computers even with the same operating system. But what the application.persistentDataPath does is it keeps a reference to a location, a folder location on your hard drive where Unity knows it can safely store persistent data. So the actual location for this will vary from computer to computer, but you can know that this variable, application.persistentDataPath, always keeps track of a location where we can store persistent data. So in this dm.save function, we're piecing together a path. We're saying this folder plus gamesave.xml file, and so when we run this save game function, it will generate this XML file containing all of our game data. So that's a good way to go ahead and create a save function. I'm going to press Ctrl S on the keyboard to save all of that data, minimize monodevelop, and Unity goes ahead and compiles that data. Excellent, we've now completed the save game function. Next up, I'm going to be looking at creating a load game function. Here we'll code a restore game function into the gamemanager.c# class, and in many respects this will work like the reverse of the save game function. But there are some significant differences that I want to point out. So I'm just going to bring the cursor in here and press Ctrl V on the keyboard to paste in the relevant code, and here we have the restore game functionality. So here right now we've got the restore game function, and the very first thing it does before it restores a game is it uses the system.io file exists function to check to make sure that the relevant XML file storing the saved game data actually exists on the local storage, because it's only if that file exists that we can even restore the game. We can't restore data when there isn't data that exists, so right now we have to check for the existence of the file. And then we call the DM, the data manager.load function, passing the application.persistentPath value with the gamesave.xml, and this goes over here to the data manager class and it calls on the load function that we've seen already, which uses XML serializer to deserialize the XML data into the game data object. So let's switch back to the game manager. This means that after we call dm.load, we know that the game data class, the game data member here, will contain all of the saved game data that we need to load back into the level. So the way this works is we cycle through all the boxes in the game data. So we read back from the XML file just exactly how many boxes were saved. We cycle through that number, and then we update the relevant crates in the level to their relevant positions, rotations and scale. Notice here in the position we're creating a new vector. Let me just move over a little bit here, and we're passing in the transform.x, y and z data into a vector3 constructor here. And also here we're creating a new quaternion based on Euler values, that is degree values on the x, y and z axis, and you can see those values passed in here from rot x, rot y and rot z. And the same for local scale, we're creating a new vector3 structure, passing in those values, and we're also updating the is on destination, and we do this for each and every box that has been saved. And then finally we update the player transform. That is, we update the position, rotation and scale of the player. So in calling this function, really, when we call this restore game function, we load back the game data. So that really is the core functionality that we implement into the game manager class relating to the save game and restore game. But there still is some more work to do, and we're going to consider what that is next. Now, of course, I've said before that the application.persistent data path value differs across operating systems and computers, but that whatever it is, it always expresses a folder on the local computer where Unity knows that you can store persistent data. Of course, when you go ahead and save that data to that location, you might want to know where that folder is on your computer, so that when we finally come to save this gamesave.xml file, you can open that up in Notepad++ or any text editor that you choose and examine and edit that data. So how can we know what this value is? Well, there's a really easy way to do that. We can call upon our trusted friend debug.log, and it's really simple to use. So I'm just going to scroll up here to say the start function. Let's say I want to know what the application.persistent data path is. I can simply type debug.log, pass in application persistent data path, press Ctrl S on the keyboard to save those code changes. Let's just minimize mono develop here. I'm going to switch to the console over here, and I'm going to press play on the toolbar, and you'll see here printed in the console here, I've got the full path, and it tells me what it is to the application here. So I've got the full application path. I know what this is now. I can go ahead and pick out the relevant XML data that has been saved. For you, the location will be different, but just be aware that you can use debug.log to print out the application.persistent path. So that's a really easy way how you can find out what that value is and how you can access your save game data. So now it's time to create the remaining functionality for the game manager.c# class that will let us save and load our games completely. So I'm just going to start by scrolling down in our source file here. I'm in the game manager.c# class. I'm going to scroll down to the start function that we created before, which you can see here, and here we've created the start function where we use the player preferences class to determine whether the player has previously got a save state session and whether we should load that level back. Now we know that if the player has this last level flag set in the player preferences database, then they will have previously saved their game at some point. And here we actually load the level. But if we enter this code block, we know that, for example, we want to restore the game from the previous session. We want to restore the state of the level. So what I want to do here is I want to call on the restore game function. That will restore the game if there is a game remaining to restore. So I'm not going to press Ctrl S to save those changes. But of course, what about saving the game? Well, for our game, we know that really we want to save it whenever the player terminates the gaming session. So every time they quit the game or exit the game, we'll want to save the game state, because that's the point where playing stops. We want to save it so that at a later time when they play again, they can resume that session automatically. So I'm going to scroll down because I'm going to insert a new function, which is a Unity API event that we can have called whenever the application is terminated. It's a special event known as onApplicationQuit, like so, and you can assign this on any mono behavior object to receive a notification when the application terminates. So in this function, I'm going to call save game like so and press Ctrl S on the keyboard, and that should be everything that we need to do to save and load our games. So let's see this in action. I'm just going to minimize mono develop, and I'm going to get started at saving our game. So now I'm just going to press play on the toolbar. Let's just press play here. and we begin at the second level. We know that we should have done so because the player preferences class stored the last level we reached, which was the second level, but notice that everything now begins at its default starting position, and that's because previously we hadn't coded the XML functionality to save the position of the player and the boxes. And notice that we didn't get any error generated because when this level started there was no game XML file to restore from, but if you remember we have that function, the system.fileIO, which checks whether the file exists. Because it didn't find a save game file to restore, it didn't bother executing any of the restore functionality. But I've loaded the game up here, and what I want to do is to make some changes that are going to be restored. So I'm going to move some of the boxes out of their default positions. Let's just push this box forward onto, let's say, its destination here. Just going to push this box around here onto the destination. I'm also going to move over here and bring this box forward onto its destination, like so. And I'm going to move another box, but not put it onto its destination point. So I'm going to move over here, for example, to this box, and I'm going to push it forwards like so. And I'm going to have the player stand in the corner around about here. And I'm going to press the play button on the toolbar to stop the application. And when I do this, the onApplicationQuit function will be executed in the game manager class to save the game state. So I'm just going to press this button to stop playback, and I'm going to bring in a Windows Explorer window. You can see here in this window that it has generated a gamesave.xml file which contains the game's data that we've just saved. So we can confirm that the file is created. I'm just going to bring this Windows Explorer window out of the way and press play on the toolbar again to resume our game. So this time when I press play we should begin from the second level, and it should restore the box and player positions. So let's press play. And you can see straight away the player is standing in the corner of the room where we left him. This box has been pushed forward by 1, and we should have also 2 boxes on the destination points. And we'll take a look at these over here, and let's walk forwards just a bit more. Yep, and there are the 2 boxes that we pushed onto the destination points. So this has successfully saved the state of the player and the boxes. Actually, if I press the stop button now and I press play button again, you'll see the player is now standing here because it's saved their position. So that's splendid. Let's just bring back the Windows Explorer window, and let's just open this gamesave.xml file in Notepad++ just to confirm that these settings are working and saved as intended. So here in Notepad++, we know that, for example, 2 of our boxes are on the destination. So let's just expand the box data tab and take a look at the different boxes. So that one's not on the destination, and again we can say that one is on the destination, the second one, and the third box, that's not, the fourth box, that's not, the fifth box, that's not, and the sixth box, that is. So we know the second and the sixth box are on the destinations, and they're the only 2. So these 2 boxes are on their destinations, and indeed this is how this is reflected in the scene. So we know that it's saving out this data fine, it's saving out all the transformation and position data in the XML. Of course, we could actually come in and start editing this data in the text file, and everything would work great because we would save this and it would be updated in the game. This gives us a great way of debugging and seeing the data that we're saving, being able to change it if we need to. And so everything's looking pretty good. We're now able to save and restore our game in 2 senses. We can load back levels we've resumed previously. We can also load back all of the data that we've saved in the level, the position of the player and the crates. Things are looking good. I want to now talk about a potential bug that arises simply because of our load and save game functionality and how we can go about correcting that. You'll see here in the player controller C# class that I've coded in the handle input function. Let's just scroll up a little bit. We've got the handle input coroutine, and here I'm responding to the R key on the keyboard. I'm saying that when we press the R key on the keyboard, I want to restart the game, and it calls on the game manager.restart level function to do that. And all that function does is use the application.loadLevel API function to simply restart the same level. You can take a look at that if you like. It's in the game manager.c# file. I'm just going to minimize mono-develop. Let's go ahead and play our game and see what bug occurs. Well, here we are running around in our second level. I'm going to start moving some boxes around. I'm going to push this box forwards into the corner. Now when I do this, I make the game unwinnable. So at this point I'm going to want to restart the level. So I press the R key on the keyboard and it simply restores the level. And you can see this box has been pushed back to its default starting position. Now I'm going to push the box forward, push it into the corner, and again I've made the game unwinnable. But this time I'm just going to exit the application with the game in an unwinnable state. I'm now going to press the play button on the toolbar, and notice the level begins in the unwinnable state because that was the last state of the level. Well, you might think that's no problem. I'm going to press the R key on the keyboard and again the level begins, but because I press the R key and it loads the level again, every time it loads the level it detects that there's a game to restore, and it just so happens that the restore game we want to put back is always in an unwinnable state. So every time we restart the level, every time the level is reloaded, it continually brings back the save state, and we know the save state is an unwinnable state. So effectively what we want to do is say that every time we manually restart the level, we don't want to use this restore game data. We actually just want to use the default and initial state of the level. So in the next video we're going to get started at correcting this bug. Now to solve this bug we need to realize that the game needs to be restored on one occasion and one occasion only. The only time we want to restore the game from the XML file is the very first time the game begins. On every other occasion when the player presses the R key on the keyboard and the level is reloaded, we want to reload the level back to its initial state and not the state in the save game data. To accomplish this and to solve this bug, I've created a new class called level counter, and I'm here in the very first scene, which is scene 00, and I've added a new game object called level counter, and I've assigned it here, you can see, the level counter component. And if I bring up mono develop, you can see here we've got the level counter.c# script, and it's a special type of component. In the start function you will see that I've called upon the don't destroy on load function, passing it the game object, and what this effectively does is it says never destroy this object. So what does that mean? Let's just minimize this here. It means that when the level changes from level 00 to level 01, this level counter object will move with it. It will persist throughout all the levels, and so every single level can keep track of whether the game has started and whether we've loaded a game previously, and the level load counter will increment to 1. Let's take a look at this. I'm going to switch over here to the game manager class and scroll down to the start function. So we've got the start function here. We check with the player preferences class if the level counter object, if the level load times is 0 or less, then this is the very first time that the player has started the game, in which case we do want to resort to the save game state. But once that has been loaded, the level counter is incremented, and we know then that the game has been restored at least once, and that we never want to restore it again unless of course the player terminates the game and starts it again. So this will help fix our problem. So let's just take a look at this in action. I'm going to press play on the toolbar and we begin here in the first level. So I'm just going to walk around and push a box onto its destination here and complete this level. And in fact, when I complete this level, what you'll notice here in the hierarchy panel is that the level counter object will move with us into the next level. Level 01, the second level, doesn't actually have a level counter object at all. It doesn't need one because this first level has one and it will be taken with the game. So let's just push this box onto its destination and we'll move over to this box here. Push that onto the destination, level complete, and now we move to the next level. But notice now we've taken the level counter object with us. So the level counter object is now with us. So here we've got our level. I'm just going to exit now, and when we press play on the toolbar, we will resume playback back at this second level here. Now what I'm going to do is I'm going to push this box into the unwinnable state that we've seen before, and I'm going to exit the level. Now I'm going to press play to restore the game. Notice that we restore back to the unwinnable state, because we've restarted the game. But if I check the level counter, you'll see the level load times is now 1. It's not 0, which is where it begins. So this time, if I press the R key on the keyboard, it will restore the level to its initial state. You can see that here. I press the R key again, and notice that every time we restart, the level load times is incrementing. It's going up by 1. So now we're always resorting to the initial state and not the save game state. Of course, if I go back to here and push that back into the corner, exit the game, press play again, we begin in that unwinnable state, but I can easily fix that now. I press R on the keyboard and it restores back to that initial state. So that is how we can solve this kind of unwinnable game state bug using a level counter object. Well, congratulations, you've now reached the end of this course, and I've had a great time coding this box pushing game. Our game has explored many Unity features, including level design, light mapping, light probes, skeletal animation, inverse kinematics, particle systems, chase view cameras, and not forgetting load and save game functionality. Right now, spend some time giving your game a solid test, and well, why not try adding even more levels? There are really so many level configurations possible with these assets, you can end up making a huge game. So I hope you've enjoyed this course and found it useful. This has been 3D Motive, and I'm Alan Thorne signing off. Take care and happy game development.